just to check that after the build. Within Control Center, they've added automatic sacrificial towers. Anybody that has taken the Insight class from me previous to the 9.1 update, I've gone through and shown you how to manually make the sacrificial tower by drawing a circle, copying the layers through the height of the part, going into Control Center, taking out the center of them so it's just a tube shell and all that. But they've now realized the importance of that, and they've added that as an automatic feature on 9.1, and that is something that I'll show you in a bit. They have changed the basic to sparse / smart transition for support material, and essentially this makes it smoother on the top layer, so when you have a down-facing layer, it makes that smoother when your model material is building on top of the support material. There's also a tall part stabilization, which if anybody has built any tall or thin parts and had to deal with the part being fragile and falling over during a build, which I've run into numerous times, previously the fix for that was doing a surround support structure. Part of the problems with that, and that function works fine, but when you're building a tall part and it's surrounded by support, you're adding a whole lot of time by doing the material changeover to lay down the support material. But what they did is this tall part stabilization builds kind of a wall next to the part, and it has fingers come out and actually touch the part in a few spots. So when you're building a tall part like that, it's being stabilized by model material and not support material, and therefore it reduces time, and you still get tall part stabilization. This is also something that I will show you. Moving on, they've improved some contour linking between contour to raster linking, contour to contour, and raster to contour contact. Again, these are things that I can't really show you because I don't have anything to compare it to. They've also changed some of the functionality of custom groups, where now the center wheel on your mouse, you can scroll through the names. Not a super important update, but an update nonetheless. Also within Insight, under File and Preferences, you can change the direction that the center wheel zooms. So previously you only had an option of one direction. Well, if you're used to something else, you can go in and change the direction of the wheel. There's a few, they call them change requests, and these are internal software things, again, that I can't really show you. So we'll start by showing you the Sacrificial Tower. So what I'm going to do is I'm going to go through the whole functioning how I used to do it, and then I'll show you how easy it is to do it now. So what we used to do is I would draw a circle. I'd draw a circle, and then I would have to copy it through the height of a part. So let's say the part was 200 layers tall. So now I have my 200 layer cylinder, and I run toolpaths on that. And if you look, the part is solid. So then what we would have to do is we'd have to go in, go to custom groups, start a new custom group, and where is it? Uncheck the raster, so there would be no raster fill. And now if you look, as I scroll up through this part, it's just a single contour. So that would create a hollow tube that wouldn't really use much material or take that much time, but it's still, you'd have to go through and draw it and go through the steps of making a custom group and modifying it. Well, now I'm going to bring up Control Center here. If I go into options, and I just have a part on here just to have a part, if you go under options and you check this include Sacrificial Tower and hit OK, it includes this part. So I used to do it as a circle, but they do it as a bow tie. That's what they decided to do, and it will automatically always put the sacrificial part over here. The function of the sacrificial part is during material changeover, it sort of wipes the tip on the part over here, and then the head doesn't have very much distance to go before it starts building over here. So you get less ooze, and it ends up helping to get rid of the start-stop point, the little ridge that'll build up. It also helps prevent embedded material, for whatever reason, embedded either material or support material into the model, because if it's going to wipe it somewhere, it's going to drop it off on this, and then this is just a throwaway. You'll also notice that over here on the list, it always puts the Sacrificial Tower as the first thing. Though it's named or numbered the second part, because it brought it in here as the first thing on the list, it will always build this first. And even if you copy, I don't think I can put that many. Yes. Even if you copy the part and the numbers, it's 3 and 4 are all that, and all that, the Sacrificial Tower is still hanging out at the first in the list, meaning that it's going to be built first. So that's the Sacrificial Tower. Again, it's under Options and Include Sacrificial Tower. And once you have this checked, it defaults to that. It will always put a Sacrificial Tower in until you uncheck that. So that's going to do it for that. And now the next thing on the list is the alternative raster fill. This is a function that is, again, new to Insight. So I'm going to draw a little model quickly and show you that and how to use it. So I'll draw a box, and I'm going to do the same thing. I'm going to copy it through Z. We'll make it, I didn't do that right. Draw the box. I didn't hit OK. So now I'm going to copy it, 100 layers. There I have my box. If you want to see, there's my box. So I run toolpaths on that. It's now a solid box. And as you guys have been familiar with, sparse is usually squares. So we'll do that. And you'll see it's squares, or it's rastered, wide rasters that alternate directions. So when you look at it when it's built, it's essentially squares. Well, now there's a function where you can change what that looks like. And that is found under Custom Groups. And we're going to do a new custom group. I'll put this over here. So I want to make the whole part a custom group, but I'm going to include under here sparse fill controls, and it says use alternative sparse fill pattern. And you click that and you have 3 options. You have hexagonal, porous hexagonal, and sawtooth. And I'll show you what each of those are. So I'm going to make my whole part a custom group. And right now it's set up for porous hexagonal, so I'll just go to hexagonal. So you can see instead of having squares, it's now a honeycomb shape. The best I can figure from personal experience with that is that it will help increase strength of the internal strength of a part in at least compression, because as you look, as I scroll through, it's each one of those hexagons are stacked on top of each other. So you'll get a whole pile of the hexagons, so it'll be the hexagon all the way, or honeycomb all the way through. The other option, or the other feature with this, is when I've printed out small squares like this with the hexagonal fill, I've noticed that torsionally the model is stronger as well, so it has more of a resistance to twist, and that's nothing that I've officially measured with instrumentation. It's just things that I've noticed handling it. The other option we have as we go down is something called porous hexagonal. So I'll change that. So if you look, it's a different pattern here, but if we go up 10 layers, it goes back to the normal hexagonal. 10 layers up, it changes to that. 10 layers up, it changes back. Actually, I'll do 2 layers at the same time so you can see what they look like when they overlap. The function of this is it helps with dissolving cores. So this was specifically designed, as I've been told from the Stratasys guys, that the composite people doing soluble cores, where they build their model out of just support material, then they'll wrap it in a composite carbon fiber or something like that. They cure it, and then they dunk the whole thing to soak out and dissolve the core of it. So this way they can do more organic shapes and difficult shapes that were previous to this a lot more difficult and expensive to do. So now they make it a lot easier. So the function of this porous hexagonal is that it's not continuous all the way up. So when you soak this part, all the waterworks, the solution, can get into the entire thing instead of having to start here and wear this or dissolve this away and then dissolve this and so on until the whole part dissolves through. This way you have surface contact with the solution on the entire inside of the part, and it makes it dissolve more readily. The last option we have here is Sawtooth. So check that. The Sawtooth, I've asked some of the Stratasys guys, and they didn't really have a good reason for me. So this is just an option. So if you notice, the contour, or the toolpath here, does kind of a sawtooth motion. Instead of running all the rasters in one direction and then going in the other, it's running them in lines, kind of like the Charlie Brown stripe on his T-shirt. So it's a zigzag all the way across, and then it comes down and does the next layer. I don't have a specific reason or benefit to that, but that's just a new update. And as far as that goes, that's it for that. Personally, I like this hexagonal. I think there's going to be a lot of people are going to have a lot of uses for that. Also in here, it says alternative fill cell size. You can change how big or small this is. So if I make this 1 inch, I go through and I run these, it makes the cells larger. Or if I go in and I say 0.01, they're going to be tiny. Apparently I can't go that small. So 0.1 is as tiny as I can go. And now you have a tiny structure depending on what you need. So the next thing we're going to go into is the wall stabilization. And I'm going to build a quick model here to show you that. So I'm going to go in, draw a box. Essentially, this is going to be a thin wall. And I'm going to copy that. We'll copy it 300 layers. So now if you look, I have a thin wall. Potentially a part that doesn't have a whole lot of a footprint. So if you built this in the traditional sense where it's only going to layer support material right underneath it because it doesn't quote-unquote need it all the way around, then there's a good potential that this model can fall over during the building process. So what they came up with is something called a stabilization wall. And what this is it builds a structure next to this that basically supports this. So this is found under support and stabilize wall. And what you do is on the top of your model, you define how high you need it to be. So in this case, the model is 300 layers tall, and I could have it go to layer 150 out of 300, or I can go to the top layer. In this case, I'm just going to go to the top layer. So I'll click the top. So I'm at the top layer of the model, the top layer that I want this stabilization wall to continue to. And you click a point on this. And this is going to define how much of the part or how wide that stabilization wall is. You click and highlight there. So it's going to start at that point. You hit the plus, and then you go to your end point. And you highlight a section right there. And when you hit the check, it automatically draws something in from your start point to your end point, and it has all these little fingers. Now this whole structure is going to be one single contour or one single tool path wide, the entire height of this part. So what I'll do is I'll run toolpaths, and I'll shade toolpaths so you can see better, and I'll show you what this does. So if you look, I'm going to start scrolling down. Actually, we're going to scroll in tighter here. So here's the end of the finger, and generally this is where the stabilization wall is going to be. But every 10 layers, and this is adjustable, if you look, it actually inserts for a single layer, it overfills and builds into the model, and this is where the stabilization occurs. So the layer interval is available over here. You can change how deep it penetrates into the part, so they're only going in 5/1000ths. You can change the layer interval, so if you want it to happen every layer, if you want it to happen every 5 layers or 20 layers, you can change that there, and how deep it overfills into the part, and how wide these fingers are. So that these are 2 inches apart, and you can make it so they're an inch apart, a half inch apart, whatever. So as the model builds, 1 layer out of every 10 gets inserted into the model. So this structure, and I'll show you the whole wall here, this structure will then help support this wall so it doesn't fall over. So I've had some issues with parts that have fallen over that I've had to go through and do surround supports. But now, in this case, if I run supports and then run toolpaths again, we start down at the very bottom layer, and I have my bed of support, and then my model, and that's it. So the rest of the height of this part, as I go up, and it's just kind of going slowly, is only model material. So this will in turn take something that without supports would not take a whole lot of time but fall over, but then if you did a surround support would take just an ungodly amount of time. Now this takes it and makes it stable and has the ability to build faster. So that's that function in there. Let's see if I can. Okay, there's another function in here under your support parameters, support, setup, and then the advanced parameter icon. First checkbox here is use model material where possible. The function of that is if you have something that you have a lot of supports, or it has a big overhang where it builds a support tower, what it will do is it will, for most of that support tower, it will build that as model material. So only the very base of it and only the top few layers that that your model itself will then need to build on will be support material. The function of this is basically time. So instead of, again, having that material changeover, which adds 30 seconds per layer, which doesn't seem like a lot, but when you get into 300 layers or 1,000 layers or 1,500 layers, what's 30 seconds times 1,500? That's a lot of hours. So this has the function of potentially cutting down on a lot of build time. But it's only for structure support towers that are not coincidental to your model itself. If it determines that it's too close or anything like that, then it'll put regular support material in there. But it's also a default function, so you can click that, and now anytime I build something, it will use support where possible. And I think that's really going to do it for me. That's about it. If anybody has any questions, go ahead and type them into the box, and I'll open it up for questions now. If anybody wants to contact either me or Jeff or whoever about some of the features that I've talked about here for either more of a description or how you can use it on your specific models and stuff like that, feel free to contact me or Jeff, and eventually we'll get a hold of me. So I'm going to go ahead and open it to questions now. So anybody has a question?